Welcome all. I'm M. Saraswati, Associate Professor from Panimalar Engineering College. Today my lecture is on registers. First of all, what is a register? A register is nothing but it is a group of flip-flops. Each flip-flop is capable of storing one bit of information. Already in last lecture, I have taught about this flip-flops. An n-bit register consists of a group of n flip-flops capable of storing n bits of binary information. So suppose I want to store 3-bit means I have to take 3 flip-flops to form a register. The register consists of a group of flip-flops and gates. See, the flip-flop holds the binary information and gate determines how the information is transferred into register. A register capable of shifting its binary information in one or more directions or both the directions is called a shift register. Okay, now what is this shift register? See, a shift register is nothing but the data in a register can be moved from stage to stage within the register or into or out of the register upon application of clock pulses. The data can be entered. So entered is what you say it as write, and retrieved. Retrieved is what we say it as read. It can be done in serial or parallel form. The serial form means bit by bit, one bit at a time. Parallel form means all the bit at a time. On the basis of the way the data is entered and retrieved, the registers are classified as serial in serial out, that is SISO, serial in parallel out, SIPO, parallel in serial out, PISO, parallel in parallel out, that is PIPO. It is also called as buffer register. Now, a register is nothing but that allows each of the flip-flops to pass the stored information to its adjacent neighbors. Okay, and the basic data movements in shift registers are given below. Okay, so let us see one by one. So first thing is serial in, shift right, serial out. Okay, so this is called serial shift right register. So the register moves by bit from left to right. That is from your left to the right. This is called as serial in, shift right, serial out registers. Next is B. Okay. So the register moves bit by bit from right to left is called serial shift left serial out register. You can see your data is given from your right side, and it is moving one by one to your left side. So this is called as shift left. So your shift is happening towards your left side. That is why it is called as shift left. Okay. Now the diagram is C. Okay. C diagram. The register that receives all the data at the same time is called parallel shift register. You can see at a time you are going to give all the data as your input and you are going to get your output one by one. That is why it is called as serial out. You are giving your data parallelly, so it is called as parallel in. At the same time you are giving your all the 4 data. So it is called as parallel in. But your output is serial. That is one by one it is moving. That is why it is called as parallel in, serial out. Next is serial in, parallel out. So you are going to give your data one by one and output is taken at the same time. So that is why it is called as serial in, parallel out. Okay. Next is parallel in, parallel out. This is also called as buffer registers. Okay. So you give your inputs at the same time and you take your outputs at the same time. So this is called as buffer registers, which we maximum use it for delaying the circuit. For giving delays, we use this register or temporary storage register. So next is rotate right. So rotate right. See, the register that shifts the data bit by bit towards the right, as well as you can see it is moving bit by bit towards its right, as well as it rotates the data. You can see there is a rotation here. The last data is once again given to the first register. That is first flip-flop. Sorry, my first flip-flop. So the last flip-flop output is once again given to the first flip-flop as input. Okay. So this is called rotation. So you are rotating the data anti-clockwise, right side. That is why it is called as rotate right. The last diagram is rotate left. You can see the register that is shifting the data bit by bit, one by one towards the left, as well as you can find a rotation in clockwise towards the left. That is why it is called as rotate left.